Welcome to Clean Architecture with ASP.NET Core 3.0. My name's Jason Taylor and I'm an SSW solution architect. I've been developing now for 19 years and I've learned that the most important principle is KISS, or keep it simple stupid. And today, I'm going to show you the simplest approach to enterprise application development with clean architecture. Let's get started. So with clean architecture, the domain and the application layer are at the center of the design. This is known as the core of the system. The domain contains enterprise logic and types, and the application layer contains business logic and types. The difference being that the enterprise logic could be shared across many systems, whereas the application logic or the business logic is specific to this system. Now, rather than have core be dependent on concerns such as data access and infrastructure, we invert those dependencies. So presentation and infrastructure depend on core, but core has no dependency on either layer. Now, this is achieved by adding abstractions or interfaces within the application layer, which are then implemented outside of the application layer in other layers. So, for example, if we wanted to implement the repository pattern, we would add an iRepository interface within application and an implementation within infrastructure. Now, with this design, all dependencies point inwards. So you can see that core has no dependencies on other layers. Now, presentation and infrastructure depend on core, but not on one another. And that's very important. We want to make sure that the logic that we create for this system stays within core. If presentation, for example, took a dependency on infrastructure so that it could send some notifications, that's logic. And that logic now has to appear within the presentation layer, and it has to orchestrate that interaction between presentation and infrastructure. We don't want that to happen because we can't reuse that logic. We want a system that's going to last 20 years. And if we've got a front end with an ASP.NET Core Web API, well, that's not going to be there in 20 years. We need that logic inside of core where it's isolated from all of those things. So this results in an architecture and design that's independent of frameworks. It doesn't require the existence of some framework or tool. It's testable, and it's easy to test. Everything in core is isolated from the outside world, and it contains your most important system logic. So we can 100% unit test that logic. It's independent of the UI. So right now, as I mentioned, I'm using ASP.NET Core Web API with an Angular front end, but I might want to change that. We're all getting a little bit sick of writing JavaScript, right? So we're going to switch it over to Blazor soon. And with all of my logic inside of core, that's not going to be so hard. It's independent of the database. Right now, we're using SQL Server. With the same design, we've also used Postgres, SQLite, and we're going to try it out with Cosmos DB as well. It's independent of anything external. In fact, core doesn't know anything at all about the outside world. And that's what makes this design so great. We've got all of our logic encapsulated within core, isolated from the outside world, and that will make a difference between a system that lasts 3 years and a system that lasts 20 years. Let's take a look at a couple of examples. When I first started talking about clean architecture last year, we used Northwind Traders as a sample. Why? Because Northwind Traders is cool, and I wanted to show the world. Now, I wasn't wrong. This repository on GitHub now has over close to 3,000 stars and almost 1,000 forks. And as a result of that, there's a great big community behind this project. And I want to take a moment to thank them. Thank you for your support. Thank you for your pull requests. Thank you for the tough questions. You've really helped to evolve this solution to become what it is today. So based on this, I've gone ahead and created a clean architecture solution template. So I wanted a very simple file new project experience, right? Coming back to KISS, keep it simple. So if you want an excellent file new project experience with a clean architecture solution, you can use this template. If you want something cool, check out Northwind Traders. Let's take a look at an example. So you can see here on my GitHub repo, you can access the Northwind Traders solution or the clean architecture template. 1 second, please. There we go. Quick game, too slow. Okay, let's try that again. There we go. So this is the Clean Architecture Solution template on GitHub. You can see that it's set up as a GitHub template, so I can actually just control-click on that and create a new repository from the Clean Architecture repo. So I just give it a name, and I'm ready to get started. But for my experience, I wanted an actual .NET Core solution template. So to get started, you can actually run .NET new install Clean Architecture Solution template, and then to create a project, you can go .NET new CA solution. Let's have a quick look at that now. So if I create a new folder for GOTO Copenhagen, jump into that, and then we go .NET new. This only has to be done once, or when you want to update the package. Clean.architecture.solution.template. So we can install the new project template. That'll install, and then it will give us a list of all of the project templates that are available from the command line. So if we scroll back up here, you can see the Clean Architecture Solution template at the top, and its short name is CA-solution. So we can run that now, and that will create the project. So what it actually does is create a project with all of those layers and all of the infrastructure in place ready to get started, because this is something that I was doing manually each time I had to create a new client project. So if we have a quick peek in here, you can see that it's using the correct namespacing also based off the project folder that we used. Jumping into source, you can see that we have 4 folders: domain, application, infrastructure, and web UI. And then jumping back into tests, you can see that we have test projects for each of those layers as well. So what you get out of the box is a template that gets you up and running quickly. We've already wired up kind of the database and ASP.NET Core identity. We've provided solutions of everything that goes into the application layer, domain layer, and infrastructure layer. So it's really easy to get started. So I won't run that one because it'll have to restore a bunch of dependencies, but we can have a look at this one here. So you can see here's the Clean Architecture Solution template in Visual Studio, basically ready to go. There's a README, which explains a little bit about it and shows you how to get up and running. That's the same README from the GitHub repo. And that's it. So very easy to get started. Okay, so key points of this section. So the domain contains enterprise-wide logic and types, and that can be shared across multiple systems. Application layer contains business logic and types, and that's specific to this system. Infrastructure contains all external concerns. In previous versions of this talk, and in previous versions of the Northland Traders solution, I separated out persistence and infrastructure into 2 different layers. But I found it simpler just to bring them together. I mean, what's simpler than 2 projects, right? 1 project. So I merged it together. A lot of the dependencies were similar, so that was easy. So presentation and infrastructure depend only on application, but not on each other. And infrastructure and presentation components can be replaced with minimal effort. Let's take a look at the domain layer. So within the domain layer, we have entities, value objects, enumerations, logic, and custom exceptions. We're going to have a look at each of those in turn. So for the remainder of this talk, we're going to be looking at each layer, and I'm going to be making key points on these layers so that hopefully if you take a look at this project or the template later, you'll be able to get up and running quickly and understand how everything fits together. So the first thing I want to show you is this to-do item entity. So I've got a really nice to-do item sample in this project. I should show you that now. So if you go Control F5 or F5 on this solution, this is what you'll get. You'll get basically the starter Angular template with a complex to-do list component. So it allows you to manage numerous lists and numerous to-do items, and there's lots of nice little features in there for working with lists and list options and to-do items. And the wonderful thing, of course, about building a to-do list is that you can also use it to store your requirements as you go, once you get it to a certain point. So you can see all the things that I've checked off there. I haven't asked for a code review. That's probably bad. I did ask for a code review, but it hasn't been done yet. So Let's have a look. Oh, I also have OpenAPI integrated into this solution. So you can click on API, access Swagger UI, and it's fully integrated and fully automated. So with this solution, when you go .NET New CA solution, it's set up so that it will generate the OpenAPI specification automatically. It will render Swagger UI automatically. It will also generate an Angular TypeScript client and all of the associated data types needed to run the front end. We'll have a look at that later. But the first thing I wanted to look at was this to-do item DTO. So one of the very simple key points that I make is that you shouldn't use data annotations within your domain model. And because we don't want to clutter our domain model with data annotations. In the past, they were used for validation and for object relational modeling by EF Core. But nowadays, EF Core doesn't use it for validation at all. It only uses it for the object relational mapping. And the alternative is to use Fluent API configuration, which provides a much more powerful configuration system anyway. So we can just go ahead and remove those. And I also want to talk about value objects. So in this solution, I've got an example of an AD account value object. Okay, and so you can see that a value object is a complex type and it doesn't have an identity. And why would I create an AD account value object? Like I could store an AD account just as easily as a string, right? And that's what I want you to think about. When you're defining your entities and you define something that's a primitive type, think about, is it really a primitive type? Do all strings represent all value objects, do all strings represent all AD accounts, or are AD accounts a little bit more complicated than that? And the answer, of course, is, well, AD accounts are more complicated. They consist of a domain name and a username in a certain format. And when we work with an AD account, we often want to access, say, the domain name or the username or the whole thing. And so if we use a string, we have to write logic associated with interacting with that value object somewhere in our system. Now, new developers are not going to know where that logic is, and it's going to appear all over the system. By instead using a complex type, such as an AD account value object, we have a place to store all of that logic. And that makes it very easy for users to work with our system. They don't have to think, how can I access the AD account, just username part? There's a property for that. Unfortunately, with Entity Framework Core, one of the features it has is the owned entity types. And it's very easy to then configure that value object in using the Fluent API configuration. So you can see here, we have a model builder entity called order that owns one shipping address. And what that's going to do is it's actually in this order entity, when it relates that to the relational model in the database, it'll store an order table or an orders table with a column called ID, and then it will have a column called shipping address underscore street and shipping address underscore city. So Entity Framework Core handles all of that for us. So when we use these value objects in this way and we configure them using the owns one type, we don't have to worry about converting that back from our object model to a relational model and the other way. It's very simple. So it's a great approach. So one other thing that I wanted to mention, and this is again about making it easy for new developers, is to always initialize your collections. So you can see here I'm initializing the items collection, and also recommend to remove or simply set the setter to private. And why do we do these things? It's about forcing developers into the pit of success. We want to make it easy for them to do the right thing and hard for them to do the wrong thing. And so if we don't do this, new developers might say, okay, I need a to-do list, so I'll go var to-do list equals new to-do list, and then I'll initialize the to-do items collection because that's what they've been used to doing. But if we set this to private, they actually can't do that. And what's more, they never have to worry about whether it's initialized or not, because whether they're creating it themselves or it's coming back from EF Core, that collection's ready to go. So that's something that they no longer have to worry about and makes our code simpler, more concise. One of the things that I didn't show you in the AD account value object is an example of a custom domain exception. So you can see here that if for some reason I failed to create the AD account from the account string, it throws an AD account invalid exception. Why would I do that? Well, it's simple. The AD account invalid exception is much easier to understand and debug than an index out of range exception. Okay, so we can create these exceptions for these expected domain type events. I've also added a few features in here just to help people get started. There's the auditable entity base class. Any entity that derives from that will automatically have those fields populated when the changes are persisted to the database. So it'll store the ID of the user who created the entity, the date and time that they created it, and if it's being modified, the user ID who modified it, and the date and time that they modified it. And all that's necessary is just to derive from that property. It's kind of a starter sample. You can definitely build that out into something more complex. Now, there's also some sample unit tests associated with this. At the moment, it's just for the value objects, but at least it shows you how to get started. So you can see that when you're working with a value object, it's really easy to create one based on an account string. You just say account.for. We've got a toString method, which we can ensure returns the correct format. We have an implicit conversion operator, which makes it easy to convert from an AD account to a string just via assignment. We have an explicit conversion operator, which makes it easy to cast from a string to an AD account. And we have this exception, which is thrown in the case that the AD account string is invalid. So when we talk about the value objects and all of the logic encapsulated within it, you can see that we have a really simple place to encapsulate a whole bunch of logic that we don't have to have in some helper class that new developers won't be able to find. Okay, so the key points. So avoid using Dart annotations. They clutter our domain model, and we can use Fluent API configuration, which we'll see when we look at the infrastructure layer. Use value objects where appropriate. I just want you to think, is it really a primitive type, or is it more complicated than that? Will I have logic associated with that type? Create custom domain exceptions to make it easier to work with your system. Initialize all collections and use private setters, again, to make it easier to work with your system. And automatically track changes with the auditable entity base type. So now we'll have a look at the application layer. So within the application layer, we have interfaces. Our interfaces that are defined within the application layer and then implemented in the outside layers, such as infrastructure. Our models, our view models and DTOs. Our logic, our commands and queries. We'll talk about that shortly. Our validators, and of course, again, our custom exceptions. So everyone by now has heard of CQRS, but if you haven't, it stands for Command Query Responsibility Segregation. And with CQRS, we separate our reads from our writes. When people talk about CQRS, they say it's great, it maximizes performance and scalability. But for me, it's all about simplicity. Because with CQRS, it's easy to add new features. I just add a new command or a query, and it's also easy to maintain. My changes typically only affect one command or query, and that means that I have less breaking changes. What's more is that if you're writing CQRS, you should also use Mediator. Those two are like the perfect couple. So with Mediator, we define our commands and queries as requests. And that means that the application layer is just a series of request response objects. And that might not sound like a big deal, but it's what happens next. It's the ability to attach additional behavior to any request that comes into the system. So with Mediator, we can attach behavior before and or after each request. So if we need to implement some cross-cutting concerns in the application layer, then we can do that very easily. So for example, if we wanted to validate every single request that comes in through the application layer, well, we can do that, and that's already in this solution. So let's have a look. Oops, get rid of that. Okay, so you can see in the application layer, I basically have a single common folder and then 3 feature folders. So within the common folder, I have some behaviors, so those are mediator behaviors for those cross-cutting concerns, some custom exceptions, some interfaces for interacting with infrastructure, some mappings, we'll talk about that later, and some models, those are shared models. But inside of this to-do list folder, I have some commands and queries. You can see everything's very neatly organized and easy to find. So I've got a query here. I've got an export to-dos query, which will export a CSV, export the to-do list as a CSV. I've got a get to-dos query. Let's have a look at this one. This one's kind of nice because it's made up of DTOs and view models. So you can see here, I have a get to-dos query, and it consists of a query, which could also be a DTO. So the query itself is a DTO. Now, I don't have any properties that I'm passing in with this query, but it wouldn't be much to say add pagination and say we could start to add things like page size and current page and that sort of thing. Okay, some of the commands have properties that you can have a look at. You can see that I've nested the handler. So with mediator, when we define our commands and queries as a request, we're basically defining an iRequest, which is the query, and an iRequest handler. So it separates the request from the handling of the request. I'll just zoom that in a little bit more. And so you can see I've nested this, and this is something that I've done to improve the discoverability of the queries. So when you actually go to the to-do list controller, that's where the query is invoked. And you can see here that we're using mediator to send a query. And we all, for this one, because there's no properties, we just specify get to-do's query. If there were some properties like the pagination, then we could just pass that back from the client as follows, or you could use a request object if you prefer. But what I found is that when developers saw this, they would go Control F12 on get to-do's query, and they would come to a file that contained just the query. So it was hard to kind of understand and then find the handler. Actually, you have to go to Solution Explorer and then go one down and double-click on the handler. So by nesting the query, or just by putting the two classes in the same file, you improve the discoverability, which is great. So let's have a look at this query. So we've got a query, which is a request, and it's going to return a to-do's VM. The to-do's VM has everything that the view model will require to render the to-do's view, which includes a lookup list of priority levels and the to-do lists themselves, which is of type to-do list DTO. Let's close that. I think I pressed that wrong. And to-do list DTO contains the DTO properties. Wait, 12. There we go. So the query returns a to-do's VM, and then the handler says, okay, this is the get to-do's query handler, and I handle requests of type get to-do's query, and I return a to-do's VM. Then down here, we've got the constructor. We're injecting our dependencies, and here we have the implementation. And so the thing that I really like about this, the thing that makes this very simple, is that this is the business case of getting a list of to-do items, okay? So obviously there's some requirement behind that. The business has come to me and said they want to implement that. Sorry, I pressed F5, I think. And I've been able to encapsulate everything that's associated with that business case in this one file. And what's more, I also have all of the files that are associated with this business case in this one folder. So when I need to change this feature, I come to this single folder and everything that I need is here. I don't have to jump around to multiple folders. I don't have to jump around to a DTOs folder or a view models folder. I don't have to go to a handlers folder or a queries folder. It's all here. And what's more, because it's co-located like this, I'm actually discouraged the sharing of this code. I don't want people to reuse this code. I want this code just to be used for this business case. And you might think that's kind of strange, but if I do that, I don't have breaking change. And if I start to share it, pretty soon we're going to start to see conditionals appearing in there. And they're going to be conditionals for separate use cases, for certain queries, and it's just going to make things more complicated than it needs to be. So I co-locate these things together, I make it easy to change, and I avoid breaking changes. And I think that's a really good approach. So you can see in here we have our commands. Everything's very nice and easy to find. We've got a create to-do list command. And it's also very simple. We've got our DTO. All we need to create a to-do list is a title. And we've got the handler, and that's got all of the logic associated with it in creating a to-do list. So I want to show you some of the cross-cutting concerns. So if we jump into behaviors, you can see I have 3 behaviors implemented. I have a request logger that logs every single request that comes into the system. I have a request performance behavior that logs warnings for any request that takes too long. And I have a request validation behavior that validates every single request that comes through the system. It's very simple to set these up. You can see zooming out, with just a little bit of code, I'm actually logging every single request that comes through the system, including the user ID who initiated the request, the username, and the request itself. And that's not just the name of the request, it's the actual DTO. It's the request and all of the arguments that were associated with that request. So if I have a problem, I can go to the log, I can grab that DTO, I can create a unit test, I can see that test fail, and I can fix it. It's a simple thing. It's 32 lines of code, but with it comes a great amount of value. Because remember, everything in the application layer is represented as a request. All of the requests come into the system either through a command or a query, and I'm logging all of those. What's more, I'm validating all of those. And so I have a request validation behavior. So this runs before the request, and it basically says, okay, for this request, this DTO, this command or query, try to find any validators, and if there are validators associated with it, collect up all the errors, if there are any, and then if the failure count, if the error count is not equal to 0, then throw a validation exception. And so every single request that comes into the system is automatically validated. All that my developers need to do, if they want something to be validated, is create a validator. So here's an example of a validator. This is using Fluent validation, and you can see that it has a rule for the title as part of the create to-do list command, and it says the title shouldn't be empty. It should have a maximum length of 200 characters, and it must be a unique title. And you can see here I'm injecting in my iApplication DB context, which is my interface to my actual DB context, and I'm checking the collection to see that that is a unique title. So this is some really powerful validation that I've created here. And that's an important point. While we can use data annotations for validation, they tend to only be suited for simple scenarios. And when we want something a little bit more complex, then we can use Fluent validation. And it provides the best result for simple scenarios and more complicated scenarios. So the other thing that I've actually implemented in this new version, in this template, is some mapping behavior. So with AutoMapper, I've done it in a way that I'm super happy with the result, and I've backed it by unit tests so that any of those runtime exceptions that used to kind of cause headaches with AutoMapper, I'm less likely to encounter. Let me show you. So if we go into this to-do list query, and have a look at this to-do list DTO, you might have noticed that it's implementing IMAP from to-do list. And so that's basically saying this to-do list DTO can be mapped from a to-do list. And AutoMapper handles the rest. Now, I also have the to-do item DTO, and it says IMAP from to-do item, but actually it's not going to be a conventions-based mapping, because AutoMapper is all about conventions. It'll do a lot for you if you follow the conventions, but then you have to specify a configuration. So you can see that while the to-do list DTO didn't have a mapping method, the to-do item DTO does have a mapping method and just specifies some configuration on how to map the priority field. Now this is actually made possible through C#8 interfaces. They provide default implementations. So I can actually say, for classes that implement this interface, if they don't specify an implementation for this mapping method, then just use the default implementation. And the default implementation basically says, well, this is just going to be an AutoMapper conventions-based mapping. So create a map from the entity to the derived type, which is the DTO. So I don't actually have to specify anything, just implementing IMAP from and the entity name is enough. What's more, I didn't want to wire all those up manually, so I've created this mapping profile and added this apply mappings from assembly method. So all of these DTOs with the IMAP from being implemented, I've got a method that will just scan the assembly, find them all, actually invoke what's called the mapping interface, and the mapping will then add that map to the profile, so AutoMapper knows about it. So then finally, when I go to use that mapping in my get to-do list query, I can just say project to-do list DTO, and it does that nested projection for me without me writing more code than a little bit of configuration for the priority of a to-do item. So I'm really excited about that. But I couldn't have written that without writing some unit tests. And so in here, inside of application unit tests, I have some mapping tests, and they're very simple. I have one test, which is actually a test provided by the AutoMapper framework that basically just says, assert that the configuration is valid for all of the map types. And that will basically say, if there's any properties that are not being assigned to, fail this test. And that's going to avoid a runtime error, and that's great. And then I have this test, which is a theory, and I just specify my expected mappings. And all this test do is create an instance and then try to map. And if it fails, we know something's gone wrong with that mapping. And so I've protected myself from probably 80 to 90% of the problems that I could run into with this technique. So very happy with that. Now, I have this dependency injection class in the application layer, which is basically just an extension method on iCollection services. And what that allows me to do is to just have an extension method that wires up all of my application dependencies so that I don't have to do it in startup.cs. Because startup.cs tends to get very bloated if you're just using the built-in dependency injection. So you can see here, all I have to do is say services.add application. Excuse me, that's very nice. So last thing to look at in the application layer is just unit tests. So you can see there's unit tests for the mapping behavior. There is unit tests for the commands, and there are unit tests for the validators as well. So you have good examples of how to test all of those elements inside of core. All right. So key points. Using CQRS and Mediator simplifies your overall design, and what's more, Mediator simplifies the cross-cutting concerns with that pipeline of behavior. Fluent validation is useful for all validation scenarios, so not just simple scenarios like data annotations. AutoMapper can be used to simplify your mappings and projections, and this application layer is independent of infrastructure concerns. We interact with infrastructure only via way of interfaces. So now let's have a quick look at the infrastructure layer. So within infrastructure, we have our persistence concerns, our identity concerns, so we're using ASP.NET Core Identity. File system, we've got some examples of CSV files. The system clock, we've got an abstraction for working with the system clock, because that's a dependency too, and API clients. So big question, unit of work and repository pattern. Should we implement these patterns? So show of hands, who thinks we should still be implementing these patterns? So about 5 people, and I'm going to take a leap and say that the rest of you think we shouldn't be implementing these patterns. Well, the interesting thing is that we're all right. That is the correct answer. Whether we think we should implement them or should not implement them, that's correct. We'll get into that in a second. But first, with EF Core, it's not always the best choice because EF Core insulates your code from database changes. EF Core uses a provider system, and it's simply a matter of you bringing in a NuGet package for SQL Server or SQLite or Postgres or Cosmos, whatever it is that we want to use, and we can change that out. So DB context actually is a unit of work, and the DB set actually is a repository. So if we're just trying to implement those patterns for the sake of having those patterns and programming in that way, we already have that with EF Core. In the past, say EF6 and earlier, we used to implement the repository and the unit of work so that we could do write effective unit tests. We don't need to do that anymore since we have the EF Core in-memory provider. We also have the SQLite in-memory provider, and they can be really helpful in kind of using those tools as testing tools to write unit tests. So with that in mind, what do the experts think? So first we have Jimmy Bogard, creator of AutoMapper, Mediator, and chief architect at Headspring. And he says, I'm over repositories and definitely over abstracting your data layer. Then we have Steve Smith. And Steve Smith's been a Microsoft MVP since all time, and he was a Microsoft Regional Director for 10 years. And he says, no, you don't need a repository, but there are many benefits and you should consider it. When Steve said that, he's been really diplomatic. If you've listened to his podcasts, listened to his blog posts, and looked at his conversations on Twitter, he's definitely pro-repository. And he has a lot of really, really good designs on how to create a great repository and why you should be using it. Then we have John Smith. So he's the author of Entity Framework Core in Action. And he says, no, the repository/unit of work pattern isn't useful with EF Core. So with that in mind, when the experts don't agree, what should we do? Well, it's really simple. We just need to remember that the repository and unit of work is just design patterns. Okay, if it solves a problem we have, that's great, use it. If it doesn't solve a problem you have, then don't use it, because that would just introduce unnecessary complexity. So what sort of problems could a unit of work and repository design pattern solve? Well, one very simple problem is the dependency on the Entity Framework Core framework. If we didn't want our solution to be dependent on that framework, then implementing the unit of work and repository pattern would solve that problem. Another problem is if we wanted to limit access to certain entities. So we were going to create order and order details with order at the aggregate root. Well, then we could create repositories only at the aggregate root and force developers to only update orders with the collection of order details. They wouldn't be able to update an order detail individually, and therefore we'd be able to have lots of logic and validation associated with that. So just think, any design pattern, does it solve a problem I have? Great, use it. Let's have a look. So inside of the infrastructure layers, we see we have 4 folders. We have files, which is that CSV helper example that I've put together. We have identity, which is my concerns related to ASP.NET Core identity. We have persistence, which is my Fluent API configurations for my entities, my DB context and my DB context seed. And we have services, and at the moment there's just a date time service in there so that we don't have a dependency on the machine clock. Let's have a look first at the Fluent API configuration. So you can see that it's quite simple. Here, I've got a to-do item configuration and a to-do list configuration, and that just allows me to define how that entity will be mapped to the relational model. And to wire that up, all I have to do is say apply configuration from assembly. That's built into EF Core now as of EF Core 2.1 and specify the assembly. Now you'll note that I've left this base.onModel creating statement. Now in the past you didn't actually need to leave that in there, so if you've written code like this you've probably just left it out and it's worked just fine. Well, it's not the case anymore if you're working with ASP.NET Core Identity as a version 3 and upwards. It actually does have an implementation in the base, so you'll leave that in, otherwise you'll run into an error and add it back in. So when you're creating these configurations, I want you to remember that EF Core is a conventions-based framework. So the first thing that you want to do is make sure that you understand the conventions. And don't create configuration for conventions, because you're just making it more complicated than it needs to be. For example, you could say something like this. Excuse my typing. You could say that that property is a key, right? But you don't need to do that. The fact that it's named ID means that Entity Framework Core will automatically assume that it's a key. And so then in the to-do item entity, it has a list ID, and it based on the name of that list ID and the name of this property, it assumes that that's a foreign key and maps it as so. So always, when you're working with a conventions-based system, know the conventions, because it's going to make it much simpler for you to work with and means that your code is going to be simpler as a result. So now, having a quick look at the DB context, you can see that in here we've got our identity concerns being wired up. And we also have this save changes async method, which I've overridden. And you can see here that this is where I've implemented the auditable entity functionality. So it basically looks to see if the entity is being added or modified, and then sets those properties using these 2 services. So very simple and something that you can build on. So inside of identity, we've got the application user. We've got this identity result extensions, which I built to make this identity service a little bit simpler. So for now, I've just created a single identity service. A lot of the time in the past, I might create a user service and a role service and that sort of thing. But the concerns for this application are relatively simple. But what you can see is the identity service is implementing the identity service, which is inside of the application layer. So when I need to write logic against identity, I'm just writing logic against this service. So I can change this implementation whenever I want. I could move away from ASP.NET Core Identity. So you can see there's some samples in there of working with identity. Okay, so it's important to note that no layers depend on infrastructure. It's completely isolated from the rest of the system. And it also has a dependency injection extension. And in this extension, I've wired up all of the dependencies that are associated with infrastructure. So you can see there's the database, there's the interface, which I use to interact with the database. There's some test configuration for Identity Server. In the back end, we've got lots of unit tests that are working with Identity Server and testing against authenticated controllers. So there's good examples of that. There's the configuration if it's not part of the test environment. And that's it. So again, all of this logic has been moved out of startup.cs into this extension method so that all I have to do within startup is just say add infrastructure. So you can see I pass through the configuration and the environment, so I have that information available. Inside of the test folder, there's some integration tests which you can take a look at, which are all about testing that auditable entity logic. Okay, so key points. Infrastructure is independent of the database. We can switch out a provider and choose a different database solution. This solution, however, that I've built is not independent of Entity Framework Core. I've kind of gone all in with Entity Framework Core, so if I do decide to move to a different ORM in the future, I'll have a little bit of pain there, but I'm okay with that. I've been using EF for, I don't even remember how long now. So use Fluent API configuration over data annotations. It's just a better approach. It does more, and it means that your domain model's not cluttered with data annotations. Prefer and know your conventions. Prefer conventions over configuration. Automatically apply all entity type configurations. And no layers depend on the infrastructure layer, e.g. presentation layer. If we do, that will result in logic being created in the wrong places, and we need it to stay within core. Okay, finally, the presentation layer. So within the presentation layer, it can be whatever we want. We've kept all of the logic inside of core, so really the UI that we create is very simple. We have well-defined view models, we have well-defined queries and commands, so the interaction's being made as simple as possible. So it could be a single-page application, Angular, React, or Vue. It could be Blazor. Web API, Razor Pages, MVC, even web forms if you prefer. Let's have a look. So one thing that I want to show is a typical example of a controller. Whoops, don't know what happened there. So in this example of a controller, you see the DB context is being injected directly into the controller. Entities are being returned from the controller, which is a bit of a no-no. It comes with a whole host of issues that we don't really want to have to deal with, security and complexity. And all of the logic's kind of, as simple as this logic is, all of the logic is within the controller. And that's because we didn't give ourselves any other choice. When you inject something like a DB context, which is such a low-level concept, with something like a controller, there's no place left to put your logic, okay? But we've avoided that problem with this solution because we're using CQRS. We've moved all of our logic into commands and queries in the application layer. So this is a typical example, but let's have a look at the same controller in the clean architecture solution. So you can see with this controller, we don't even have a constructor, right? Why have a constructor? If you don't have a constructor, it's simpler. So we've just got a base class. The method for get just basically sends a mediator request. Mediator's coming from the base class, and that's it being injected by a property injection. The method for getting by ID is just basically 2 lines of code. 1 line of code for create, a few lines of code, maybe we don't need that, for update, and 2 lines of code for delete. So there's absolutely no logic in there. We've essentially reduced this controller to infrastructure. It does one thing. It takes in a request and returns a response. So it's as simple as can be, and there's no logic within there. All of the logic's been moved into the relevant commands and queries. So you can see also that when we talked about the to-dos view model, that for each query, we're trying to return a well-defined view model so that when the client receives that response, it has everything that it needs to render that view, whatever it may be. And that means that the client doesn't have to make additional API calls to get more information. So encapsulate everything in well-defined view models and make it simpler again. So I mentioned that OpenAPI is running behind the scenes in this solution, and I'll give you a quick look at how that's set up. I also have a blog post on it that you can check as well. So essentially, with OpenAPI, I prefer to use NSWAG. So NSWAG is probably the best tool chain because it's capable of generating the specifications, it's capable of generating the clients. It's kind of an all-in-one shop, and it has a nice Windows application that allows you to specify that configuration so you can get up and running really quickly. So in this solution, in the web UI, what I have it doing at build time, excuse me, is it generates the specification, just there, and it generates an Angular client. If I can find it. There it is. Just there. And when I talk about this, I talk about how it's bridging the gap between the back end and the front end. And the reason for that is all of those really nicely defined view models and all of those nicely defined commands are generated here. And this is code that I don't have to write, but if we come down to the bottom here, so you can see, here's my update to do item detail command. So I have these types nicely defined in the back end. So instead of manually creating these versions on the front end, they're now generated. And the Angular client to access the web API is now generated. And that all happens automatically. I just have to build the web UI project, and all of that happens. If you're building microservices with this approach, you can also use NSWAG to generate C# clients. And so then you can publish those at NuGet packages and share them with the other services, depending on your approach, of course. So one of the things that I'm doing in the application layer, if something does occur, if something happens wrong, we throw an exception. And so I've created an exception middleware, which is responsible for intercepting those exceptions from the application layer and converting them into something a little bit more meaningful. Excuse me. So you see here that we've got two requests being handled, a validation exception and a not found exception. So if a validation exception is encountered, it will basically take those failures, turn it into a 400 bad request response, and return the result to the client. I'll be releasing a new version of that shortly, which will work with validation problem details, so that'll be even a nicer experience. Then we have the not found exception, and that's basically thrown when it can't find some entity when it's trying to get something by ID or to update or delete something. And so it returns that into a not found response code and returns the message back to the client. So we have that same nice consistent experience, at least from the ASP.NET Core perspective. So with those exceptions, it's really up to the client how they will handle that. And in this case, I've handled it using custom exception middleware. With identity, there's just a couple of classes in here. Under services, I've got the current user service, which will basically just interrogate the claims and find the user ID. So then I can pass that to my identity service within infrastructure and do things with that user. One other thing that I've added to the web UI is a whole bunch of integration tests. And there was quite a lot of work that went into this just because of the integration with identity. So if I zoom in here, you can see that we're using ASP.NET Core Web Application Factory to wire up all of our dependencies and spin up a host. We've got an integration test helper, a test version of the current user service, a test of the date time service, and a test version of the identity service. But with all of that work done, we actually have some really simple tests that we can write. So you can see here that this create test is referencing the controllers, the to-do items controller, and the create action. And so we have some tests written for that. So you can see I've got a helper method to grab a HTTP client, not just a HTTP client, but an authenticated client. So I've made it really easy to write these integration tests. So if you're wanting to test at that level, where you're exercising the full ASP.NET Core stack, you can, and it's simple because it's already set up. So you can see here, I'm getting my HTTP client authenticated. I'm creating a command. I'm turning that into request content, and then I'm posting that, getting a response, and just ensuring the success status code. So you can see, really simple to write these tests. And what I'm trying to do with these tests is just to verify the basic system inputs and outputs. I want to make sure that kind of at a high level, everything's working nicely. And the fact that I can write these tests and that I can write them quickly is just fantastic. So here's our delete test. So you can see that we're basically saying, hey, I've got a valid ID, and I want to make sure that if I delete that, that it returns this success status code. We don't care that it was deleted from the database or anything like that. We just want to kind of make sure at a high level things are working. We can write other tests to check that it was deleted from the database, if we get time. And this one, given an invalid ID, basically ensures that the HTTP status code returned is not found. So again, a basic system input-output test, very quick to write because all of the infrastructure is in place. So key points. Controllers should not contain any application logic. It's responsible only for taking a request and converting it into a response, and that logic lives in the application layer. We should create and consume well-defined view models. Don't make your clients ask questions. OpenAPI bridges the gap between the front end and the back end. And NSWAG automates the generation of OpenAPI specifications and clients, and we automate that using a simple MS build task so that we don't have to look at it again. So thank you for coming to my talk today. If you're keen to learn more, please grab the code and or install the template and try it out. Give it a go. I think you'll find this approach is simple to build and maintain all the way from development to production. Thank you.